Our first speaker is Marybeth Miceli. She's the president and founder of Miceli's Infrastructure Consulting.
From the first slide, you might be able to guess that my co-presenter was unable to make it today. Today, we're going to talk a little bit about integrating inspection and monitoring technologies into bridge management programs. And the process that we're going to really talk about is more how to get new technologies into the bridge market, which, since we all work on bridges, we know that this is not the most easily achieved goal. We're going to go into our 10 not so easy steps in order to get new technologies into usage in the bridge industry, and some of the ways that we might be able to shorten the process of traditional technology transfer. And then we'll go into a case study about that and some conclusions about how we can all move forward as an industry together, industry and agency together. How many of you, especially agency owners, have all the money you need for everything? Hands? Oh, I had one. He didn't think I was going to see him, but I had one. So anyway, obviously, asset owners are being asked to do more with less, always. And one of the ways that we can achieve this is through technology. Of course, there's a ton of technology out there. And at this point, you can't have somebody in the DOT who is, an expert in all different technologies. And so really, we're going to talk about how do you wade through all those technologies and maybe shorten that traditional technology transfer process, get new technologies in a little more quickly. One of the real challenges for manufacturers and technology innovators is that they're not used to the long adoption times that we have in the bridge industry. We don't really move very quickly, right? So, and they're also not used to the sales cycle. When I work with companies out of the aerospace industry, when I tell them what our usual sales cycle is, they lose their minds. They don't understand how we could possibly function, but we do. And then there's relatively few customers, right? So you're looking at 50 DOTs plus some toll agencies and other private agencies. So really, there's not a ton of customers out there either. So these are some of the challenges to get technology innovators even interested to come into the bridge industry. So this is sort of your traditional technology transfer, right? We've got, you've got your successful research, and then you go through a licensing process or some sort of IP process. And then you go to proof testing. And that proof testing takes a really long time because you're coming out of the university, it hasn't been proven in another industry yet, and then eventually you get to the green area. So how do we shorten that yellow phase? And maybe shorten that red phase as well. So for traditional tech transfer, these are some of the challenges that are unique to surface transportation, right? So you need to adopt cutting edge technology in order to address our aging assets, as well as personnel shortfalls. We know that there's less and less people working for the DOTs, and so we need to figure out how to use technology in a more, in a smarter way. That said, we are a little conservative in the bridge industry. We tend to not want to do something unless somebody else has already done it, right? So the first question anytime you go in to talk to an agency is that, well, who else is using this? And they like to hear that people in their general area is using it. So if you're going to talk to Virginia, they want to hear, well, Maryland's doing it or West Virginia's doing it. So we're a little conservative. We're very reliant on specifications, so if it's not already in specification, generally there are quite a few owners who don't even want to hear about it. And there's a really large inventory, and that presents its own challenges. Also, the process varies from state to state. So some states have their own way of doing things and have their own research and development group. And some have a regional working group. So there's all different ways that getting technology into the states can be achieved. And we're going to talk a little bit about that. In general, it takes a long time. So this is what we're looking at. something that I've been working on for the last 7-8 years is actually something called parallel technology transfer. And this is basically where you take a technology from another industry, like aerospace or oil and gas or nuclear industry, bring it into the bridge industry because it's already proven. It's already been used for decades in other industries. So the people in the bridge industry are a little more willing to accept it. Not willing to accept it, but a little more willing to accept it. So this event essentially shortens the yellow phase and basically eliminates the red phase. So we go straight to the licensing and then into proof testing and market education. And then the green phase of successful commercialization can be longer. So these are those 10 not so easy steps. And I'm not gonna spend too much time here because we're gonna go through each one. And some of this is gonna be advice for how agencies can adopt technologies earlier and maybe some of the useful ways to adopt a technology and get actionable data in the end. And then some of these will be advice for manufacturers and technology innovators how to effectively communicate with the DOTs. And for those of you who don't work for a DOT or a turnpike or something like that, I'm just going to use DOT, so forgive me. Okay, so the first thing is you need to identify the need. So there are a lot of technologies out there that are really great, but if nobody actually needs them, your successful commercialization is going to be pretty poor. So there's various ways of doing this. There's formal customer discovery. I know that companies themselves can do this, but I know that also TSP2 has reached out to several of the agencies on various different technologies. In fact, one of them was that the bushing repair that they talked about. So they were asking who owned it and is there a real need for it and how successful it's being. There could be some sort of RFP or grant from maybe NSF or maybe DOE, somebody like that is looking for a technology. So sometimes that is a way to identify a need that it actually formally comes out like that. And then the AASHTO subcommittees, and of course the NCHRP research needs statements, right? So these are some really great ways to identify the needs. The other one is you really need to determine, even if that research statement comes out, you really need to determine, is it really a need in the marketplace or is it just, it would be nice? Because eventually you want to, as a technology innovator, you want to eventually be able to make money on what you're producing. And then, of course, you can do that through market analysis and a competitive analysis. One of the things that I really have spent a long time working on is identifying solutions in a parallel industry. And whether that's power generation, or aerospace, petrochem, automotive, construction. And then, does it exist off the shelf or does it need to be adapted for the bridge industry? Does it need to be ruggedized? Are people used to using it in a lab and not in the field? And so there's a lot of different questions that come up. Can it be adapted? And then will that company have the patience to go into the bridge industry and knowing those long sales cycles, knowing the long time for adoption of any new technology and the limited number of clients? So I can't stress this one enough. So asset owners generally don't have a lot of very specific expertise in an area. So, they tend to have to be jack of all trades. And when it comes to new and emerging technologies, it's really important to get information from other experts in the field who can vet the technology, have the time to talk to the references, really go through the information to verify that the manufacturer is really, above board and that you're going to get real value out of using the technology. Additionally, experts can help write the RFPs and scopes of work. I will say that I see a lot where RFPs come out for example, structural health monitoring, and there's not a clear understanding of what they've asked for, and that in the end, whether they're actually going to meet their end goals. So it's really important to engage the people who are very, very deep in the industry to help you write the RFPs so you get actionable data in the end. I will just mention again that technology advancement make it harder and harder to be an effective jack of all trades. So this is the really fun part for technology innovators, trying to find the lead state, the early adopter, and the champion within the DOT. The different states that like to do early adoption sort of changes every 5 to 10 years. And there's various reasons for this, whether it's funding or whether it's the fact that maybe one state used to adopt a lot of technologies very early, but then they got burned by some of them. Now they don't want to try anything at all. It happens. They'll all remain nameless. But it's very important to find those early adopter states and find the champion within there that's really looking at the risk-based inspection, that's looking at asset management as a whole. It makes it much easier. And I think all of us saw Chris Keegan, again, with the bushing repair. And he was not only an early adopter at Washington State, but also a champion of the technology because he sees the results and he then shares it with his peers. And that's super important because, as I mentioned, everybody likes to know what everybody else is doing and where else it has been used. So one of the things is when you're bringing something from another industry into the bridge industry, we've got different materials, we've got different applications, different stress ranges. You've got all sorts of stuff that you need to be able to verify in the laboratory if it's not already being used in a state. So laboratory testing is very important, and some states have their own labs that they like to use. Independent laboratories out there as well that can do testing. But this is super important because if you go to use a technology and it's not already proven and you haven't looked at all the data, you can very easily get burned out by it not doing exactly what you've asked it to do or you not meeting your end goals because the technology wasn't used properly. So this is the big one, right? The field demo. So this is a really effective way of getting some real value from a new technology and really assessing what that value is going to be for you moving forward. So I strongly suggest, most of these demos, most of these companies will give you a free demo. However, it is nice if you can find a way to pay them because eventually these companies that are coming in, as I mentioned, have the long sales cycle, and they need to show some sort of value of being in this industry. The other thing is group proof testing, and I spoke about this a little bit, but as you know, TSP2 has working groups, AASHTO has what was formerly known as TIG, to do proof testing in a group with grant money. And this is actually extremely effective, and it's very common in other industries. Oil and gas loves this. They utilize this all the time. They pool their money together, and they get group proof testing so that the technology owners don't have to go to every single owner and say, let's try this out. Group proof testing really benefits everybody, and it speeds the acceptance into the bridge industry. So this is fairly new. People have been sharing data for a long time, but these knowledge transfer databases are being more widely used now in the bridge industry. Definitely TSP2 has these knowledge transfer databases, specifically on the pavement side. They're really good about this. They share a lot of information. And obviously conferences like this are designed to share that kind of information, but there's 3 concurrent sessions, so everybody can't be everywhere. So these databases are really coming into their own now. So the Long-Term Bridge Performance Program database, ABC database, that's out of FIU, and then the AASHTO has their own National Technology Performance database as well. So these are really super important to, and I think that they're going to continue to be more and more important. Once you get all of the information in, right? You've done the demo, you're starting to sell to DOTs. The really important part is to get this stuff into specification, right? Because most states, other than the early adopters, a lot of states don't want to try new technology until it's well established and into the specifications. So, for example, and I'm going to bring up the bushing again because this will be my case study at the end, But the bushing example is, Virginia's written it into their specification, New York's written into their specifications. So there's a couple different areas where they're slowly getting more and more into it. However, if we can speed the way that AASHTO looks at different technologies and adopts them and gets them to write them into specs, then we can more easily get the new technologies in there. And obviously, this is probably going to become a huge problem for drones, right? So each state is sort of doing their own thing. But the more that we can standardize the industry, the more easily we can adapt the technologies and adopt them into the bridge industry more effectively. Also, if you don't know about this, AASHTO, National Steel Bridge Alliance, and TTCI in the railroad industry, they all put out technical briefs on different technologies, and these are hugely helpful. So if you're looking to really consider a new technology, it's very important to go and look at some of these documents that have already been done. TTCI does a ton of work out there because they have, again, it's pooled group funding. So it's the Association of American Railroads, the railroads all come together, put their money in, and they fund some of these studies that are really used by the whole industry then, and then their member organizations can then try them out on their facilities. So I really encourage you to look into this kind of stuff when you're considering adopting new technologies so that you really have a full understanding of the capabilities. Procurement options. So this is a huge challenge. You may get through all of this and everybody wants to use the technology that you're putting forward, but if you can't respond to the bridge industry in a way that owners need you to, it becomes very difficult. Owners like to, the bridge industry is a net 30 industry, right? We bill and then everything says net 30 and then you pay 30 days later or 90, 120. Anyway, so some of the industries don't work that way. Aerospace, for example, aerospace is all PO based and people tend to pay for something before they take delivery, which is, I would love to see any DOT that would like to pay for something before they get it. So, so in any case, procurement challenges in the bridge industry are very unique. And so it's very important to understand that the manufacturers have an understanding of how this is going to work and that everybody's on the same page. Particularly because a lot of times in the bridge industry, you need to respond to emergency situations. And so, at least for technology innovators, I will say that it's very, very important that you can be flexible and respond to the bridge owners how they're able to procure your technologies. And I think we need to work together as a team to figure out how that best can be done. So the owners need to be upfront about how their whole system works, because it does vary from state to state. And then the technology innovators really need to be able to work with them and figure out a way it's going to work for everybody. So I've spoken quite a bit about the FTI StopCrack EX case study already, but it's so important because they came into the industry about 8 years ago. From the aerospace industry. And this technology had been used in aerospace for 40 years. It's not like this was a new concept, but we had never heard about it in the bridge industry. And even from there, we really needed to go through laboratory proof testing to really show that the technology itself exceeded much more than what was needed in the bridge industry. And then from there, do some do some field testing. And as you can see on the bottom there, you've got a conventional crack arrest hole that's going through the weld material. This state will remain nameless. And then you've got the bushing repair on the right that is able to go in more quickly because it's not going through weld material, but then also be a lot smaller and tangential to the crack. And in the end, this is much more effective. But this is a great way to communicate to the owner the value of the technology. So you're really comparing apples to apples. This is all on the same crack, which is great. And I can't stress enough how important it is to mimic real-world situations for the DOTs so they can really see the value of what you're providing. And as I mentioned, it's been written into specs in New York, also in Virginia, which is fairly new. I also mentioned the industry champion, and I will say that Chris Keegan has been really great for them, very instrumental, and he's been very passionate about sharing that information with his peers because he sees real value in what's being done. It's also being taught in the NHI course. And I say 6 years in, that's sort of when they came out of laboratory testing. But I'll tell you, they're still not, as an aerospace company, they're still not prepared for what is happening in the bridge industry. Everything's moving more slowly than they thought it would. There's not as many customers as they thought there was going to be. So there's some real challenges for getting people and technology innovators from other industries to come into this industry. And I think as an industry in general, we need to figure out how can we shorten that time. And lastly, we're not quite to widespread adoption, but they are in 10 states. But you can imagine, after 8 years of starting to pursue this, the fact that they've only sold to 10 states can be quite frustrating for any innovator. So my conclusions are, we really need to standardize the process for adoption or guidance to help owners, and to shorten that time for technology manufacturers. And we can do this by utilizing parallel technology transfer, because if we use traditional technology transfer, that time to adoption is even longer. We can also get more use out of organized funding, group funding, so that we can sponsor the research and everybody can benefit from it, so that technology people don't have to go state to state to state doing demos. And it's important to realize, like I said, that not every company has the patience for this industry. I think we're all here because, even though we could be making more money elsewhere, we're all here because we want to help the public safety. But not every company's into that. And then also, by working together, I think we can figure out a more standard way to do this and to shorten the time for adoption. And so I really encourage everybody to think about how you, in your role, can help shorten this and help the adoption of different technologies, and then talk to your peers about how that is going to help you make better bridge management decisions, better asset management decisions, and better repair and retrofit decisions. So, and I just want to acknowledge WSP, because Kelly Severance was my co-author on this, even though she was unable to be here, and FTI for letting me use all of their information, and MFS for helping me to be here today. So thank you.
In one of your early slides where you were talking about the steps, you said to search in the parallel industries, all those different ones, and I was just wondering if you have any thoughts on how you do that. I mean, I suppose one way would be to attend a conference like this in every single industry, but that's certainly a huge effort. How do you suggest going about doing that?
So, disclaimer, I am on the board of ASNT, but groups like American Society for Non-Destructive Testing, they have inspection and monitoring technologies from all the different industries. So they bring together oil and gas and nuclear and automotive, and there's a lot of people all sharing technology-based. So you need to go to conferences that are more technology-based rather than preservation-based, and sort of think outside the box of, okay, here's a technology, and how can I utilize that to make my life easier? And then BINDT is another one. That's the British people. But they do a lot of condition monitoring, which ASNT doesn't get as involved in.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.